Hi guys, let's go ahead and do the error and power portion of Unit 6. Most of Unit 6 and Unit 7 are all of those different types of inference of making intervals, using z-scores, t-scores, sampling distributions, inference tests, confidence intervals, what changes the size of the intervals, all that, which is in a different review. But this little piece is kind of a chunk I can do by itself. So here we go. So what we want to remember is that definition of the type 1 versus type 2 error. Type 1 error, so type 1 error, if the null is really true, but we get a sample that causes us to reject the null, and then we think HA is true, that's a type 1 error. type 1 error. And so then the probability of that happening, so if the null is really true, but we accidentally reject it, then that size of the rejection region, which is alpha, is going to be that proportion of samples that would lead us to create a type 1 error. All right. So here's a context example of that. So an environmental scientist wants to test the null hypothesis that the anti-pollution device for cars is nothing special, doesn't do anything, not effective. Under which of the following conditions would a type 1 error be connected? So it's not effective, okay, that's what's really true, but we get a sample that gives us significant results. And we got a sample way over here in the rejection region and went, woo, I think that's really working. So that means the scientist thinks it is working when it actually is not. And that's what A says. Okay, type 2 error. Type 2 error, that's when we fail to reject a false null hypothesis. Type 2 error, type 2 error. We didn't have evidence. We have no evidence for HA. No evidence, so we fail to reject a false null hypothesis. So we do not reject the HO, even though it really is false. Okay, so HO is false. All right. And so that sample, what happens is, we've got this data where HA is where all the data is centered, okay? And here's your HO, okay? But our sample was, say, maybe right here, okay? We had a sample right there in that section. And so it wasn't in the rejection region, so we didn't reject the null hypothesis. It was close enough to the HO that we failed to reject the false null hypothesis. Okay, so here we go. A medical doctor uses a diagnostic test. So here the null hypothesis is that the patients do not have arthritis. Okay, so we're testing to see if they can assess if they have arthritis. The alternative is that the prescribed the patient has arthritis, okay? And so we want to know, does that medicine help us decide correctly if the patient has arthritis or not? So which of the following represents type 2 error? So that means this is false, okay? Okay, but we think it's true. Okay, so the HA is the one that is really true, okay, but we think the HO. So we didn't have enough evidence to reject the null, okay? So we weren't able to determine a patient has arthritis when they really do. All right, so failing to diagnose arthritis in a patient who has arthritis, okay? So there's that one. Okay, next is power. Oh, FYI, by the way, don't forget that beta is that probability of a type 2 error. So see, if this is your HA, then your rejection region, I guess you're going to be in this section. I don't exactly know how to describe that. It's close enough in to that HA or HO that you're not rejecting. Okay, power. Power is, we want to be able to reject the null when it is false, okay? So power is detecting a false null hypothesis and detecting that there is evidence, so having evidence of an effect. So here's a lot of different ways that that can be said. Of course, our power is the probability to reject the null, if it's false indeed. Okay, so you remember that here is our rejection region for HA. Okay, but here we have beta over here on this left because we have some samples that lead us to fail to reject, so that's our type 2 error. All right, but power is all of this area that leads us to reject that null hypothesis. So this power is doing what we should do in rejecting a false null hypothesis. Okay? So here's some statements, various ways you can think about this. Power is the probability of rejecting the null when it is in fact false. Okay, kind of like what the song says. Power is the probability of making a correct decision to reject the null when it is false. Okay. Power is the probability that a test of significance you'll be able to detect the effect, okay, and have evidence of HA. Power is the probability that the test of significance will detect that deviation from the null hypothesis, and so then detect that there is an effect. Power is the probability of avoiding a type 2 error. And that is true. See, power and type 2 error add up to 1. So if you know how much this little type 2 error is, then power is 1 minus that. So let's look at a context problem of this. Here's a diagnostics test to see the medicine who believes the patient has a disease, okay? And so we want to see if we are able to detect that the patient has the disease if they really do. Okay, so the null hypothesis says, patient doesn't have a disease, okay? And then HA says we detected that there is a disease. So power would mean that we want to be able to detect or have evidence of HA if HO should really be rejected. We want to be able to reject the null if it really is false. So let's see what our answer choices down here say. The probability that the new test indicates the disease in a patient who has it. Good. So power is doing what you want to, is not making a mistake. It is detecting that effect, detecting that HA if it is indeed true. Okay? And so that's the one that B says. All right. Now, finally, we have got to know how can those things be changed? What can you control? What mechanisms do you have the ability to manage as a researcher to increase or decrease the probabilities of those events? So here I have two situations. Remember, we would draw our little circles. And so we would have the one where if the title of this little picture was increasing, then we had our arrow going up on the left and down on the right. So the way to increase power is we can increase the type 1 error, and we can increase N. Okay, because we as a researcher have control over the size of alpha and the size of the sample. Okay, so that's what we could do. That would in effect make that type 2 error go down. It would increase power, and then of course increasing N is decreasing, that variability, that standard deviation. Okay, decreasing the power, if you want to do that, that's just the opposite. Or say you want to decrease the type 1 error, If you want to decrease the probability of type 1 error, then you want to reduce alpha. You could also reduce n. That would make it more variability. Okay, so anyway, those depending on what the question is asking. And here is one contextual question. So we have a situation where the truth of the matter is 20% of all, or the null hypothesis is 20% of all students use these vending machines with the fruit juice, okay? So which of the situations down here would the power for the test be the highest? Okay? Now, one thing I did forget to mention down here is this right here. The magnitude of the effect. So how far HA is away from HO. Because if you have a situation where here's your H, if your null is true, your data is there, but if your H data is, your actual data is centered very far away, then you have a lot of data. You have almost all of your samples that will lead you to reject that false null hypothesis. So the farther HA, the actual data is away from the null, the more likely you are to draw a correct conclusion to reject HO. So then here in this case, I'm going to look for the HA that is farthest away. And that's going to be these ones here. So if in all actuality 50% of students use the vending machines, then I would be more likely to detect a reject evidence of that increase and reject the null. Then also remember, according to our picture, we want to increase N. See, to increase power, increasing N by decreasing the standard deviation. So therefore, between these two bottom sections, D and E, oh, poopy, the answer is E, not D, okay? So there's that answer on that, okay? Largest N, farthest away from the null. All right, so those are the different ways that the review of error and power and the items that affect it.